Sorry, saya lupa buka notes. In Lagrange method, rumah siapa tu? Ini anak kecil. Ada adik ke? Your own kids ke? Okay, so can you see my notes? Boleh nampak? Saya punya OneNote. So we'll stop until the first example, I think. Okay, sampai sini. So kita dapat ya. Equation of motion with the Lagrange. Tablet sangat sensitif. Tadi saya tengok daripada atas. Okay. So Lagrange method from Tuesday. Lagrange method is based on energy method. So energy method not required you to have a free body diagram. So if you can have energy, summation of the energy, then sorry. Okay, so if you can have energy equation, then you can do the Lagrange method. Okay, so this is the equation. So we have been doing example 1. From example 1, so we have our kinetic energy based on the kinetic diagram lah. In this case, we have x1 and we also have x2. If it is x and theta, then you are going to have x and theta. We'll see in another example of if you have other kind of generalized coordinate there. And then from the Lagrange method, you define Q as x1 and x2 and then compute the partial derivative or partial differentiation based on the kinetic energy and the potential energy. Okay. So then we get x1 equation of motion for x1. Let's do for x2 lah. Now we try to do x2. So I'll just put there. Next, we go for equation of motion for x2. For q2, now it's q2 which we declare as x2. Okay. So okay. Is our Lagrange equation and saya ambil balik lah, susah nak tengok kat atas ni. So I'll copy again this equation. Okey. Kita sambung untuk X2 ya. So for X2 we have partial derivative of kinetic there. But then for X2, so kita ada for X2 velocity of X2. So look at here, look at the kinetic. Okay, differentiate it on X2 dot. So kita dapat 1 is 0, X1 dot kosong lah, because you don't have X2 dot here. And then we are going to have M2 X2 dot. And then differentiate over time what you have previously. And then make it 8, we have M2 X2 double dot. Okay, now we go next. Partial derivation of kinetic also on X2. So tengok sini masih dalam T. We have T with X2. Displacement. In kinetic we don't have any displacement, so it's 0 lah. And then finally we go for potential. So partial derivation or partial differentiation of potential energy on, currently we are focusing on X2, displacement. Have a look here. It's easier if we expand it. Kalau expand lagi senang lah, nak tengok lagi senang you nak differentiate. If you're very good, then tak perlu expand pun tak apa. So X1 square minus X1, X2, and also X1, X2, 2X1, X2. And plus X2 square. Check my calculation. I always make mistake dekat tambah tolak dengan nombor-nombor ni. Selalu ada salah lah. So have a look Kalau salah bagi tahu. Okay, and then differentiate the potential on X2. So kita ada 0 for X1, and then for X2 negative K1 X1 ya, negative K1 with X1, and then X2 square plus K1 X2 sahaja, and also K2 X2. Okay, so we have done this for Q. Q is given force. And loss energy. So in this case, we don't have any given force or damper. So no given force, no damping system, no damping element. Can straight away put Q as a 0. In this case, Q2 lah. Okay. finish 8. Therefore, equation of motion for x2. Arrange it accordingly. Following the Lagrange method. According to Lagrange. Susun balik sajalah. So we have M2 x2 minus 0 plus we have partial derivation of potential, yeah. K1 x2 plus K2 x2, and we don't have any non-conservative energy there. Minus K1 x1 plus K1 plus K2 with x2. Okay. Okay, so that is one example when we don't have any non-conservative energy Q. Q tak ada. So let's go for the second example when you have the lost energy and also the given force. Okay, so we'll go for example 2. Example 2. We'll still stick with the very simple mass damper spring system. This time we add the damper. Kita tambah damper sini. M1 and we have K1 C1. K2 C2 C3 K3. A little bit different. So this is example 2. Example 1 tadi kalau tak ingat. So hampir sama, almost the same. So we have K1, K2 but without the damper. And now we increase the K, K1, K2 and K3 and also C. Yang tambah jadi 3 lah. Still the same. Given that we have X2 and X1. Okay. First, if you have the system, Lagrange method is based on energy method which you do not need the free body diagram. What you need is kinetic energy and also the potential energy. Okay, kinetic energy is based on in your kinetic diagram. Apa degree of freedom yang ada? Okay. So, general equation for kinetic, ya. T is 1/2 mx velocity square. So that is the basic equation. So in this case, what we have 1 on x1, the kinetic diagramnya, satu lagi pada x2. So the one that related to x1 is m1 with x1, so it is a velocity, plus another one is related to x2, which is m2 with x2 velocity. So if it is a theta, then you go for theta. Maknanya 1/2j theta dot square. Okay. Ada lagi? Tak ada. So we have x1 and x2 saja, our kinetic, our movement. Now let's go for potential. Potential is based on number of potential lah, spring. So general equation for potential. U 1/2kx square based on the Hooke's law. Sebenarnya this is the potential energy. Okay, so that means we are going to have three elements in the potential energy. Satu, K, this is K1 with X1. So it relates to X1 square. Second one is 1/2K2. And then you see, K2 is action and reaction force. Sini ya. I put back. This is action and reaction force. Dia ada relation between x1 and x2. Action reaction force related to x1 and x2. So that therefore you still need to make an assumption. Siapa lagi besar daripada siapa? Okay, Tuesday, Selasa kita dah tengok lah how to make a correct assumption when you have multi-degree of freedom. So you have to check. The key point is to check which one of the movement is last. Yang mana hujung? Okay, yang ni x2 x2 hujung lebih besar daripada x1. Okay, boleh? Stay with me ya. So ingat lagi ya, yang mana macam mana nak buat assumption, mana yang lagi besar, mana lagi kecil. Yang rasa tak ingat kenapa assumption x2 lebih besar daripada x1, bagi saya love. So that I know. Kalau ada yang lupa lagi. Semua like ya, semua like. I have a love. Okay, very good. So now back to that. For K2, potential for K2 maknanya dia akan jadi x2 minus x1. Don't forget the square. And then last, potential that you have is on K3. K3 with x2. Don't forget the square. Okay, once you have that, from T and U, use Lagrange. Okay, which is the Lagrange is then you can do one by one. 4 Q1 equal X1. And another one, maybe you can have 4 Q2 x2. Okay. You can do it one by one. Partial differentiation of kinetic over the velocity. In this case, x1 lah. Okay, take a look on the equation again. Okay, I try to shrink that. Okay, T bezakan kepada x1 dot. So what you will have is m1 x1 dot, and then differentiate over time what you have previously. Then we are going to have m1 x1 double dot. Again, partial derivative for kinetic with displacement x1 0. So look again, look at T. Since we don't have any displacement, so you are going to have 0 on that. If the system is very complex, you will have the displacement in kinetic energy. But then up to our syllabus, you will not find any lah. Memang tak jumpa lah. Okay, and last is potential with displacement. Okay. You might want to expand this so that it's easier to do the differentiation. Okay, I try to expand that. Hopefully I didn't get wrong anywhere lah. Okay, so let's make the differentiation here. Again, x1 here, displacement of x1. Okay, the first one we do have x1, okay, and then followed by x2, followed by negative 2, 2, then k2 x2 plus x1. So we have k2 x1 and plus the last one is on x2, so this is 0. And we still have Q satu lagi. So let's hold Q. Kita hold dulu Q. Let's do for X2. Okay, so X2 on velocity of X2. So you will have M2 X2 dot. Sama, lebih kurang saja. And then differentiate over time of what you already have above. kinetic with displacement of x2 also 0, and then potential against the displacement. Potential against displacement, saya buat tepi ni lah, dekat sikit. Partial differentiation of potential against displacement of x2. 0 plus k2 x2 minus k2 x1 plus x1 square, so this is 0, and plus k3 x2. Ceklah takut saya salah plus minus. So I'll copy that, put it here. Saya nak masuk Q. So you have Q1 here, and this one also have Q2. Non-conservative energy. Non-conservative energy for X2. Is for x1. Okay, non-conservative energy is actually Q in general is equal to partial derivative of total work against the displacement. Partial derivative of total work. So remember work, basic equation of work is force time distance. So partial derivative of total work with displacement. We go work must equal to given force minus the lost energy. Terms, given work force, because it is a work, given work force with lost energy. Lupa lah saya term, but it needs to be in work lah. Okay, so what we have is the given force. Then you have to make it into work, so times the distance. Back to the... Okay. Oh, saya tak letak work here. Let's add the work. Saya tak tambah work dalam ni. Let's have a work M2 lah. Put down here so that it's easier to have a look. So that is our diagram. Work given force. So we have F, but then it needs to be in work times the distance. Looking at this particular force, it related to x2. So your force will affect force yang ni, F yang ni, this F will affect delta x2. Saya letak delta, maknanya dia sikit lah, ni nak letak banyak pun susah juga. So dia adalah perubahan kepada x2. So this is force, this is distance, and that making it a given force. Okay. Non-conservative energy, you got added value to the work and then minus the lost energy. So lost energy is coming from damper. So kita kena minus lah. So minus C. The next one is C. And C is a damping coefficient, but then we need to have it in force. So C ni akan jadi C1 X1 dot, that is the force, times the distance to get the work done. So distance here, this one is related to the changes in X1. So this is the force, this is the distance. And minus all lost energy is minus. You kena tolak semua lost energy. Minus C2. C2 is affecting X1. Dia ganggu X1 dan dia juga ganggu X2. Yang ni ganggu X1 saja. So in this case, got X2 minus X1. And this is a force. You need to get the distance to get into work. So distance also affecting the movement of X2 and also affecting the movement of X1. So dia berlaku perubahan kepada X2, juga berlaku perubahan kepada X1. Okay, tak muat. Okay, I move this one. And then satu lagi, we have C3. C3 is only affecting X2. So you got X2. And the distance to make it work adalah perubahan kepada X2. So this is the total force. Sorry, total work. Once you have the total work, therefore, find the non-conservative energy Q. Remember, it is a partial derivative of total work against the displacement. So, again, back to For Q1, we have partial derivative of work against x1. Another one is for Q2, it's a partial derivative against displacement of x2. So we have to do both. So bezakan work kepada x1. Bezakan kepada perubahan x1. So look at force. Tengok force. So there is no x1, so kosong. Next, have a look at C1. Kita akan dapat differentiate over x1. We'll get C1 x1 dot. Okay, so this one is quite long. Of course, you can expand it. Expand saja. So that it's easier for you to do the differentiation. Saya expand ya, saya expand sini. So we have C2 x2 dot delta x2 minus x2 dot delta x1 minus x1 dot delta x2 positive plus x1 dot delta x1. Okay, so differentiate over x1. Kita dapat the first one is zero x2 x2 negative x2 ya, negative x2 C2. I'm missing C2. X2 minus 0. Another one is plus C2 x1. Saya salah plus minus ya. Saya salah plus minus ke? Macam balik. So this is plus ya. Check my calculation. Saya takut saya salah. This is minus. So I have negative C1, negative C2, x1 dot plus C2 x2. Okay. Do check kan, kalau tak nanti semua salah dengan nota-nota yang nak tengok pun salah. Okay, now we go for Q2. Differentiation, partial differentiation of total work against X2. Someone messing with my notes. Ada yang bergerak, kejap lagi saya betulkan. Okay, so for Q2 apa ejah ni? This is a collaboration notes. Kalau siapa yang tergerakkan dia, nanti semua bergerak. Apa yang hilang tadi? Work work is equal to given workforce minus loss. Work, total work against X2. So looking at F on X2, so if you differentiate F, kita akan dapat F sahaja, and then minus 0 because it is on X1, and then based on this green, yang green ni saya masukkan situ, we'll have negative C2X2 because it's on X2 plus 0 plus C2X1 dot, and then minus 0. So I'm having Q for X2 is F minus C2X2 plus, okay, saya tertinggal satu lagi ya kat atas, C3 yang ni, I'm missing this one, satu lagi, okay, minus C3 X2 dot, that is on X2. So we'll have F plus negative C2 negative C3 X2 plus C2 X1. Okay, and then combine all finding into one equation of motion. So equation of motion for X1. Kita ada M1 X1 double dot plus K. Where is my K? Yeah. equal to Q. So my Q will be negative C1, negative C2, X1 dot plus C2, X2 dot. If I do the arrangement properly, I will get plus C1, C2, X1 dot minus C2, X2 plus K1 plus K2 with X1 and then minus K2 with X2 is equal to 0. And then equation of motion for X2. So I'm going to have M2 X2 double dot with K, tadi partial derivative of U. This one, yeah. Partial derivative of U and equal to Q2. So that is my Q2 F plus negative C2, negative C3, X2 dot plus C2, X1 dot. So I'm arranging it again. Arrange tu yang ni masuk sini lah. F boleh kekal sebelah kanan, as usual. So I'm going to have M2 X2 double dot plus C2 C3 X2 dot minus C2 X1 and then plus K1 plus K2 with X1 minus K2 with X2 and then equal to F. So I have my equation of motion based on Lagrange method. Okay. Sampai situ, yang faham boleh bagi saya like, yang rasa separuh je faham, macam tak faham je, bagi love, so that I can see how many of you is actually okay. I've got love, like. If you do understand 80%, faham lah. Cuma kalau dapat soalan sendiri, mungkin agak pening sikit. Banyak love ni. Oh, I have less like. Okay, lagi. Berapa you punya ni sekarang? How many of you is in the room? 47. Okay. Okay. Separuh. Half of you. Banyak tadi lah dapat. So, pening lagi ya. Macam mana nak buat Lagrange method. Okay. So, I have another example. Let's see another example. Hopefully, you can progress up to 80% lah. Faham sikit. I'll go for example 3. Example 3. Let's combine rotation and translational. This one, the example that you have done using Newton's law. So I have K here, and this is also K. This is also K. With R, with 2R, and then let's have J. And once you have the visual or the diagram of the system, check how many degree of freedom do you have. Okay, try hold the M, moving the J, and vice versa. Pegang J, try move the M. How many degree of freedom that you have? Yang independent, the movement that is independent. So you will get, this is one of your kinetic, and another one is counterclockwise of theta. And let's have one force. Okay, that's one force there. Tu nak moment juga, moment boleh. Satu je lah. Nanti banyak-banyak pun pening. Okay. Find equation of motion using Lagrange. Okay, to find the equation of motion using Lagrange, saya dah repeat banyak kali, you don't need a free body diagram. Try to separate what you have learned using the free body diagram, Newton's law, and then the energy method. Tak perlu bayangkan free body diagram. So you have energy method to support Lagrange. Okay. Then what do you need first? Kalau kena buat dalam Lagrange, you need to have kinetic energy of the system, and then you need the potential energy of the system, and also you need the total work of the system. Kinetic, potential, and total work. So kinetic relate to your degree of freedom. Dia akan relate dengan your kinetic lah. So this is your kinetic. You tahu kinetic diagram, tahu kan? So this is your kinetic. Potential relate to potential of the spring. You have this one, you have this one, and you have this one. Okay, and total work relate to given force minus loss energy, which is temper. Okay. Kinetic, build the kinetic energy for the system. Equation kinetic energy 1/2 mx dot square. Itu memang basic saja. And then you add up everything. Okay, so I have 1/2. Now it needs to be on this kinetic. So apa yang melibatkan kat situ ada m. Kinetik lain yang terlibat, what are the other motion, kinetic motion yang ada dalam tu? Tambah ke tolak tak payah fikir, memang semua tambah je semua. So total up all the kinetic energy. So another one is just identify what are the kinetic, what are the movement that involved in the system. So another one is rotation. Rotation doesn't use M, kita pakai I or J kan, moment of inertia. So angular velocity. Anything else? Kalau tak ada, then that is the element that you have in the kinetic energy for this particular system. Okay, potential. Potential, kira berapa spring you ada. So you have 3 spring in this. So your potential energy is going to have 3 elements. The first element is, saya start dengan yang bawah ya. Saya start dengan ni. I'll start with this one. 1/2K. This particular K is related to X. And then let's go for this K. So this particular K is related to, okay, this one relate to X. So this one relate to this particular K relate to X and theta. So therefore you need an assumption here. Because this is related to action and reaction. Okay. Action and reaction force of X and theta. So you need assumption. So last Tuesday we already go through how to assume which one is larger than the other one. Yang tu boleh faham? In this case, siapa lagi besar? Okay, so this one is X is larger than theta. Okay, boleh saya dapat yang tak faham saja? Give me love, kenapa X lebih besar daripada theta? Oh, tak ada love kan? So semua boleh faham? Ada juga. Okay. Kenapa boleh X lebih besar daripada theta? Okay, one. So I repeat very fast lah. Okay. X adalah, this is the tips. It's not mentioned in the textbook. Tapi tipsnya adalah looking at last movement is larger, is the largest. So in this case, ni saya contoh sama dengan yang selasa. Pusing yang ni, satu pusingan. If you rotate that, then you'll find it will meet with theta at X yang straight ni. So after the X, there is no other direction or movement. So that makes X is the last movement. X menjadi terakhir, pergerakan terakhir, jadi kita assume dia lebih besar daripada theta. So macam mana nak tahu dia terakhir? You have to try to visualize the motion. So bulat tu bergerak, lepas tu dia boleh bertemu dengan X. X ni sebab dia menghala ke bawah, since X is facing downwards, dia dah tak boleh patah balik sini. Dia tak boleh balik jumpa dengan theta. So X lebih besar. That is the easiest way I can explain. This is my own personal tips on how to understand assumption yang ada action and reaction force ni. Dalam textbook memang ayat yang sangat common sangatlah. Okay. I think kalau yang ada love tadi tu boleh tanya peers, tanya member, how they understand macam mana nak tengok last motion, last movement. So saya sambung balik. That making when we have X is larger than theta, kita boleh dapat sini 1/2K X is going to minus the theta. But then kita kena samakan value yang nak ditolak tu. So you need to put arc theta as in deflection profile. Okay. Because it move, this rotation is based on arc ya. Dia bergantung kepada arc dekat sini ya. This is just arc. Wih, semua hilang. So dia dekat radius arc, so you get arc theta. Satu lagi last 1/2 K. Looking at this one, this particular K, this particular potential is related to arc theta. Of course, it is also an x. Then this particular x is 2 arc theta. So you will have 1/2 K. Sorry, I'm missing the square. 2 arc theta square. This is also deflection profile. Saya letak sini memo. We use arc theta or 2 arc theta because x is main or the action force. So you need to know if theta is the main, so you have to change the x. So kena terbalik lah. In that case, your x is going to be x over r. Maknanya x ni yang akan berubah lah. I mean x ni, you have to put x over r minus theta. Or 1/2, contoh ya, you are going to have x equal to arc theta, then you will have x over 2 arc, that is square. This is if theta is the last motion. Kalau theta adalah yang terakhir lah. Example. Don't confuse, this is just footnote. Okay, moving further. Kita ada 3 benda sebelum kita pergi pada Lagrange. Dan total work. Oops. Okay. Total work is the given force to the system minus the lost energy. Given force minus the lost energy. Tapi given force need to be converted into work. So kena darab distance. You have to remember that. So first, paling senang is you have F. Badan F is a force. Make it into a work times the distance. So distance here, it's related to X. So do we have any? If you have a moment at this, dekat J tu ada moment, kena darab lah moment dekat situ. So kita letak satu saja sini. And minus the lost energy, which is related to damper. We don't have any damper in the system. 0. Okay, so once you prepare this one, this is kind of your free body diagram. Kalau you nak buat Newton's second law, F equal MA, M equal I theta double dot kan, you prepare free body diagram. But if you want to do the Lagrange method, you don't prepare the free body diagram, but you prepare the energy equation. Okay, so saya kecilkan situ. Okay. Once we have T, U, and W, then proceed to Lagrange. Baru kita sambung kepada Lagrange. So, energy method is easier because you don't have to draw the free body diagram which you biasanya tak tahu anak panahnya ke mana, arrownya ke mana. Okay. So, the Lagrange. Okay, just put the equation in general. Sorry, equal Q. You can do for X and another one do for theta. Okay. So partial derivation of kinetic against X velocity. Tak nampak equation. Dah sekecil yang boleh lah tu. Saya nak menulis pun dah kecil sangat ni. So that you can have a look at the equation. Okay. Differentiate T against X dot. So we get M X dot. Another one is 0 lah. And then differentiate against time. Then we have mx double dot. Nampak dah equation kat atas. Kalau salin boleh buat lah. Kalau tak salin tak nampak ni. Okay, I'm trying my best. Another one, you do for theta. Partial derivation against angular velocity. Theta dot ya. So you will have, this is 0. Plus, look at the T. Look at the kinetic energy equation. Then you can have J with theta dot. And differentiate over time. Then kita dapat J theta double dot. Next, go for potential. For potential energy, maybe it is easier if we expand here. Kita expand lah. So I put here. Let's expand it. So we have U 1/2 kx square plus 1/2k x square minus 2 arc theta, ya, plus arc square theta square plus 1/2k for arc square theta square. Okay, so let's do it here. Partial derivative of the potential against x. Against x, kita dapat k with x plus k with x minus 0 minus 0. Sorry, saya salah. Rx ni, ya. Saya Rx theta lah. Betul ke? So we have 2 Rx with theta. Then we have k r with theta. Plus 0 saya start balik. Salah. 1/2 kx square differentiate, we got kx, and then the next one is also kx. The next one is negative k r theta. And the other one is without the theta, without the x, so kosong. Next followed with, this is also 0. Okay. Tengok dengan saya punya calculation. This is u with x. I'm missing dt with x. Okay, next is partial derivative of u against theta, against displacement angular displacement. 0 plus 0 minus k r x plus k r square theta, also plus 4 k r square theta. We have here partial derivative of kinetic against the displacement. We which is 0, and then we have partial derivative of potential against theta, then you can have that one. Okay. What else? So we have done this one, we got this one, and leaving as the Q. Q1 for X. Where is the Q? Apa equation Q tadi? Q is partial derivative of total work against the displacement. So you will see our total work is F delta X. So this one, yeah. So we have to differentiate against X. That means we are going to have F. For Q2, partial derivative of total work against angular displacement. Then you will have 0. F delta X is going to have 0, and then we don't have any damper. Okay. Once you have everything arranged according to Lagrange equation. And then you have equation of motion for X. Equation of motion for X. X. So we have mx double dot minus the 0 plus kx plus kx minus k theta is equal to f. So I arrange it again into mx double dot plus 2kx minus k theta equal to f. And then equation of motion for theta. Okay, look at the one that you have done here for theta here. So j theta double dot minus 0 plus u. So we have k x plus k square theta plus 4k 4k square theta and equal to 0. Q is 0. For theta, Q is 0. So arranging it again, I will have salah plus minus ni. Saya salah minus ya sini. This should be minus. Negative. So saya salah dekat atas, tambah tolak mana-mana lah tu. Okay, differentiation. Oh, I do get it negative here. Cuma dekat sini saya tak letak negatif. I have negative here, so I put negative here. Saya tinggalkan dalam merah ya. So there is a method to know where I went wrong. Dekat mana saya salah. Ini tertinggal lah. Okay, now we have got our equation of motion. Okay, so lepas example 3, how many of you yang love, maknanya separuh je faham. Mana yang like, which is 80% above, yang dah faham. Boleh saya dah tengok? Like 80% lebih kurang ke atas lah. Love 50 ke bawah, 50% less. Yang rasa tak faham pun. Okay, I'm getting like a lot. Okay, very good. Ada love. So I put a summary here ya. Summary. Okay. So for Newton's law, you need to be able to draw free body diagram and then use Newton's law, which is F equal ma or summation of moment equal I theta double dot lah. Okay, for Lagrange, you need to have energy equation, which is kinetic, potential and total work. Lepas tu baru guna Lagrange method. Which is minus T dengan displacement plus U dengan displacement equal to Q. Where Q is partial derivative of total work against displacement. Okay. That is the summary lah. Okay. Okay, so kita ada dalam 20 minit lagi. Saya nak bawa how to arrange the equation of motion that you have arranged into metric. Right, this one is very fast. Senang saja. Melainkan you tak ingat metric. Unless you don't remember how to build equation into matrices. Okay, so I put a new new notes lah. Equation of motion in matrices. We have another 20 minit lagi. Sempatlah. So this one is very simple. Okay, let's get, saya ambil je daripada equation of motion that we have done previously. Okay, example 1. Example 1. This one, eh? M1. Okay, this one M1. Saya copy saja. This is from our previous example. So it is example 1 lah. So we need to arrange it into metric. So that particular metric, so this is equation 1, this is equation 2 kan. For 2 degree of freedom, 2 equation of motion. So dia akan jadi the first equation. Let's start with first equation. Put in blue. M1 with X1. And then you don't have X2 in that particular equation. Equation 1 ni tak ada X2, tak ada M2. Tak ada X2, tak ada M2. So dia jadi kosong setengah. Okay, you have displacement vector here, X1 dengan X2. If you arrange X1 dekat atas, make sure all is X1 lah. It's easier. Boleh je arrange terbalik, tapi cumanya it's easier for you to have a look X1, X2 macam tu. Okay. So X1, you have K1 here. And we have K1. For X2, you have negative K1. And then equal to, in this case, it's equal to 0. So you have the 0 dekat situ. Equation 2. We only have M2 with X2. Maknanya M2 0. X1 double dot. We have M2 times X2 double dot. Okay. So dia darab dengan X1. Juga darab dengan X2 double dot here. How about K? For X1, we have negative K1. And for X2, this is X2, kita ada K1 plus K2, which equal to 0. If you want to check whether you build into the correct matrices, expand balik lah. You can expand it back. Okay, let's do with the blue one. Kita expand balik ya. Okay, M1 times X1 double dot plus 0 times times darab dengan x2 double dot. So you dapat the first one is m1 x1 double dot darab kosong x2 double dot. Okay, and then k1 darab dengan x1 negatif k1 darab dengan x2. So plus k1 x1 tolak k1 x2 and then equal to 0. Okay, check whether this is the same or not with equation 1. If you are doubting your own metric, expand it back and then make sure you get the correct one. Okay, then we can do the same with yang satu lagi. Saya buat je. Nota kita contoh tak payah. Okay. 0 darab dengan x1 double dot tambah m2 darab x2 double dot. So 0 x1 double dot plus m2 x2 double dot. Sama yang ni darab dengan x1 tambah dengan darab dengan x2. So you have negative k1 x1 plus k1 k2 darab dengan x2 and then equal to 0. And check whether it is the same with the equation of motion that you have above. Okay. Itu building or arranging your equation of motion into metric. Sampai situ dulu. Yang faham like, yang tak faham bagi saya lah. Okay, good. So maknanya ingatlah metric macam mana. Okay, good. Okay. Hopefully we don't have love lah. Okay, very good. So ada yang tak jawab lah. Hopefully yang tak jawab tu dia tahulah faham ke tak. Because if you have a look at the video later memang pening. Kalau faham dalam kelas lagi senang. Okay, let's go for example 2. Saya rasa kalau dah faham tak ada masalah ni. Laju je. Example 2. Example 2. Okay, this is example 2. Our equation of motion is lagi bawah lagi. Okay, this is our example. For your own notes mungkin kena salin balik lah. Tak boleh nak copy-copy macam saya ni. Let me get this. Okay. So our matrices will have this following element. This one is on the acceleration vector, and then you're going to have element on the velocity vector based on the equation kan. And also on the displacement. Okay. Arranging it accordingly. So, masukkan je. M1, this is 0. Kemudian for X1, C1 campur C2. For X2, negatif C2. For K, K1, K2, X2, negatif K2. And then for force metric, this is 0. For the second equation, we have 0 x1 double dot, but we have a value on x2. For C, x1 negative C2 with C2 plus C3. Okay. Salah ni. Equation of motion kita salah lah. Saya salah tulis value. Okay, tak apa, saya tulis dulu sini. K1 plus K2 negatif K2 with F. Okay. Looking at this stiffness metric, equation of motion was wrong. Okay. Metric, this equation of motion in matrices need to be able to do transpose metric. Transpose metric. Macam mana saya nak cerita transpose metric ya? Transpose metric. Transpose. Transpose metric. Example of transpose. So stiffness metric biasa kita tulis K. Transpose metric maknanya if there is one metric, ni kalau dah ingat, dah tahu ingat je lah. Maknanya one and metric 0, 0 and 2 contoh ya. This is mass metric. So if we do the transpose, it's still the same metric. So transpose metric is contoh example lah. I put M as well. A lah. One, two, three, four. If we do the transpose metric of A, dia akan jadi 1, 3, 2, 4. Okey. In order for the equation of motion to be correct, or to check, or to check to balance the equation, When one metric is transposed, it doesn't change the metric. You can see example. Mass metric and damping metric. See. Dia eloklah salah ni, so that we can explain. So this is mass metric, M, capital M. Okay. If you change the arrangement of mass metric dengan transpose, dia masih sama. Sama juga dengan ini. Kalau saya buat C metric, C. Your C metric here is C1 plus C2, negative C2, negative C2, C2 plus C3. When I do the transpose, ini transpose ya? This is the transpose. Change the arrangement of 2 and 3. When I do the transpose, dia masih sama. So this is the correct equation of motion. So probably we have made some mistake previously during the calculation. Apa yang saya salah ya? Sepatutnya K2 ni duduk sebelah sini ni. Duduk sebelah sini. Atau saya copy equation yang sama. Sorry, okay? Ya, saya copy equation yang sama ya. Let's see. Sebab nampak sama ya. Tapi ada C2 dengan C3. So probably we have a mistake here. Sini ni saya salah ni. Okay. This one ya. So I probably copying the same. Oh, saya tahu. Saya copy yang ni sama ya. Nampak ke kalau saya kecilkan lagi nampak ke? Saya rasa saya copy dia ni salah. Alamak, mana dah? M2 Sini. Salah, bawah lagi. Mana sini. Yang ni saya salah copy ni. Sebab saya copy paste dia tadi kan. This one saya salah copy. Sama dengan sebelah. Okey, kat sini ya. Ini saya salah copy. So this one. So it should be here. Yes. And also down here lah. Sini. Hopefully you don't get confused lah. Saya cuba betulkan. What's already fall. So dekat bawah ni pun akan berbeza. So we have negative K2x1 and then plus K2 plus K3 x2. Okay. Saya letak. Okey, saya letak saya. Maknanya di sini salah. So this is the correct equation. This is the correct equation. 4x2. Make sure to replace. Nota saya huru-hara tak apa. Just make sure your notes is properly lah. Replace into stiffness metric. Sorry ya, panjang sikit. Lagi saya lagi seminit dulu. So that I can settle your notes here. So, mana tu nak letak? Get everything dulu. So yang salah sini. So our K was negative K2 with x1 and this is K2 plus K3. Okay. So this is the correct when you have the correct metric, kat sinilah baru kita akan dapatkan mass metric. Tadi dah tengok dah mass metric. Make sure it is transposable, maknanya yang ni dengan yang ni bendanya sama, value dia akan sama. Okay, so this is acceleration vector. And this is damping metric. This velocity vector. So there is a difference between them when I say metric and vector. So metric is constant, stiffness metric. When it is a vector, displacement vector. Maknanya dia adalah variable. It changes according to time. Dia ada perubahan, ada x dengan t, x double dot dengan t kan. It's a function, so dia jadi vector. And this is force vector. Force is also F dengan T, function T. So from here, we are going to use it to find eigenvalue. All these matrices will be used to find eigenvalues and mode shape. So we'll go next week. Kita tengok eigenvalue and mode shape. So sebab saya salah tadi, just make sure you do for example 3. Buat sendiri pun tak apa, example 3. The one with x and theta tadi. Complete your own note, build into the matrices, equation of motion in matrices. Okay. Sebelum kita leave the room, can I have sekali lalu? Sekali lalu yang faham 80, 70, 80 ke atas, and then love yang faham less than that. So kita ada Lagrange dan kita ada building into matrices. Okay. Gua rasa 70, 80 tu you have to do the review lah. Dengar saja rasa macam faham. Okay. Okay, good. Very good. Okay, so thank you. Sorry saya ambil masa 6 minutes more than usual. Okay, complete the example. Alang-alang dah ada 3 set kan example, so make it complete lah. Okay, so thank you class. See you next week. Kita buat eigenvalue and mode shape. Anything else boleh DM saya lah, tak ada masalah. Okay, if you want to try other example. Sorry? Sorry, saya tak dengar. So, saya tengah bercakap. Kalau ada buat example lain, rasa nak tunjuk saya tengok, boleh je saya tengok sekali lalu. Kalau susah-susah, saya kena duduk kat meja lah. Kalau sambil-sambil makan ke, layan Netflix ke, boleh je tengok sikit-sikit. Okay, if you have anything, do DM me, tak ada masalah. Jangan malam-malam sangat lah. Okay, so thank you class. Bye. Assalamualaikum. Saya leave ya.
Thank you, madam.
Okay.
Thank you, madam.
Alright, thank you, madam.
Thank you, madam.
Assalamualaikum, madam.
Thank you, madam.